In this video, we will learn about the slope of a curve. One way to interpret the derivative is by means of the slope of the tangent line to the graph. In fact, the basic problem that we can encounter in differential calculus is the problem of tangents. In such problems, we will be asked to find the slope of the tangent line to the graph at a given point. However, before we attempt to find the slope of the tangent line, we must first decide what tangent line are we referring to. Is it the same line that is tangent to a circle at a given point? Recall that for a circle, the line that is perpendicular to a radius of a circle at a point P is said to be tangent to the circle at a given point called the point of tangency. However, this may not be true for a general curve. Consider curve y equals f of x and let P and Q be two distinct points on this curve. Hence, the line PQ is called a secant of the curve. If the point P is fixed, we can now think of the tangent line at P as a limiting position of the variable secant as Q slides along the curve towards P. In essence, the problem of finding the tangent line to a point P boils down to the problem of finding the slope of the tangent line at point P. The slope can be approximated using a secant line through the point of tangency P and a second point Q on the curve y equals f of x. If the coordinates of P are xy and the coordinates of Q are x plus delta x, y plus delta y, the slope of the secant line PQ through the points P and Q then is given by delta y over delta x. Since, as mentioned earlier, the slope of the tangent line at P is the limiting position of the secant PQ as Q approaches P. That is, as delta x approaches 0. And by the definition of the derivative of a function, we have the slope of the tangent line at the point P xy is equal to the limit of delta y over delta x as delta x approaches 0, which is also equal to derivative of y with respect to x, which is the same as f prime of x. We can now formally define the slope of the tangent line. By definition 6.2.1, if the function y equals f of x is continuous at h, then the tangent line to the graph of f of x at the point P hk is the line through P having a slope m at h and is given by m at h is equal to the limit of delta k over delta h as delta h approaches 0, which is equal to the limit of f of h plus delta h minus f of h all over delta h as delta h approaches 0, which is equal to the derivative of k with respect to h, which is the same as f prime of h, if this limit exists, or the tangent line is the line x is equal to h if m at h is equal to negative infinity or positive infinity. If neither I nor 2I of definition 6.2.1 holds, then no tangent line to the graph exists. Accordingly, the slope of a curve at the point of tangency is defined by the slope of the tangent line. So, by definition 6.2.2, the slope of the curve y equals f of x at the point P hk is f prime of h. That would be all for this video. I hope that you have learned from it. See you on our next video.